In the next few videos, we'll be talking about inverse functions. But before we start talking about inverse functions, we first need to understand this concept of one-to-one. Only functions that are one-to-one have inverse functions. So that's why we need to first talk about one-to-one. So what is one-to-one? I have it written here as a definition. So what basically one-to-one means is that for every value of y, there's only one value of x. Okay, remember that to be a function, we needed for every value of x, there to be only one value of y. And remember, so to be a function, you had to pass something called the vertical line test, right? Well, to be one-to-one, you need to pass something called the horizontal line test. And the horizontal line test just means, so, yes, this is already a function, so it passes the vertical line test, but does it pass the horizontal line test? The horizontal line test tests if the function is one-to-one, if there's exactly one value of x for each value of y. And so we can see here, this first example does not pass the horizontal line test. If you were to draw a horizontal line, you would go through more than one. You would go through the graph at more than one point. Okay, so this is not one-to-one. Oops. So not one-to-one. All right. So now this next one, we see that it does pass the horizontal line test. So if you were to draw horizontal line anywhere, you would only intersect the graph of the function once. Okay, so this one is one-to-one. Okay, so because this graph is one-to-one, there will be an inverse for the function that is this graph. So there is an inverse because this one is one-to-one. All right, lastly, we have this one looks like this. Does this pass the horizontal line test? So if we were to draw horizontal lines, only intersects once. But what about this horizontal line right here? At this horizontal line, we intersect an infinite number of times because there's all these points on this line here. Okay, so this one is not one-to-one. In addition to the horizontal line test, we can also see if a function is one-to-one by using algebra. So to do this, what we could do is so say, let's say f of x1 equals f of x2. So if this is the case, that these two are equal to each other, then, that implies that x1 equals x2, okay? And this will be true if the function is one-to-one. So let's test if this is true. So to do that, I'm going to go ahead, I'm going to say f of x1, I'm going to assume that it is true, okay? And then I'm going to go ahead and plug it in. So f of x1, so that would be x1 squared equals x2 squared. Okay, so now I'm going to go ahead and try to solve for x1. So to solve for x1, I'm going to take the square root of both sides. So to do that, it'll be plus or minus the square root of x2 squared. Now, the square root of x2 squared is just x2. Okay, but this is not the same as this. x1 equals x2, but here we have x1 equals plus or minus x2, right? So this function, this is, not one-to-one. Okay. All right. Let's go ahead and do the next one. Let's do this example for B. So same situation. Let's go ahead. I'll write it in blue, actually. So f of x1 equals f of x2. Let's see if x1 and x2 equal each other. If they do, the function is one-to-one. So I'm going to plug in x1 plus x1 equals x2 plus 1. I'm going to subtract 1 from both sides to solve for x1. x1 equals x2. Aha! This is the same as this. Okay? So, the condition is met. This is 1, 2, 1. This is a 1, 2, 1 function.